So now in this video, we have this integrated circuit there, the 74HC00. So there are 4 NAND gates. They are not Schmidt trigger NAND gates, so that's something to be aware of. So in any case, the only way to get the output low is to have both inputs high. There I went the trim pot high and it did not go low, and I have this jumper here that I put to the positive supply making that high, and the output did not go low. They both have to be high once I get the screwdriver in there for the output to go low. Now we don't have hysteresis, so if I get the trim pot about part way, then you can see that they kind of slide which one is on for some reason. There we go, and they're both partially on. And also with the jumper over here, now I'm getting stray signals in the air right there. We don't have a constant voltage, and so they're alternating back and forth. So now here's our schematic diagram and pin layout for the circuit I just showed you in the other short. So we got the 74HC00. There's 4 NAND gates. We're using one of them. It's not Schmidt trigger though. You don't see a Schmidt trigger symbol. So the red LED lights up when the output is high, and the blue LED lights up when the output is low. Basic stuff right there. So we'll just jump right to the truth table. The only way to get the output low is to have both inputs high. If any input is low, the output will be high. So it's the opposite of the AND gate because it's the NAND gate. So it's the AND gate symbol with a little dot at the end to show that it is inverted. And I use this top one there, A and B inputs, and then Y for the output. So we got the A input. I had a jumper that was either at the negative supply or the positive supply, and I had a trim pot where I could get close to the positive supply or negative supply to give us high and low inputs. So now we're going to cover a couple things that I didn't cover in the last 2 shorts, and I'm making shorts out of this video if you're watching the full video. So we have the 74HC00 integrated circuit. There are 4 NAND gates there. We're using number 1 only. You don't see any power pins on there, but you still have to power it. And we've got the same power pins for all 4 of them, of course. Positive supply to pin 14 and negative supply to pin 7 right there. Now, there's inputs we are not using, the NAND gates we're not using. Don't leave them floating. I put that note there, and whenever you see that, that means put the pins to a supply voltage. You could use a resistor too, and doesn't matter positive or negative. I don't think. I always check the data sheet, but in any case, that gives it a voltage that helps lock its output in place. Otherwise, you get oscillations that cause problems. So that's most of what you need to know about this integrated circuit.